going? Good day, pre-algebra. We are doing CO50 today, which is finding the slope of a line that has been graphed. And we talked about this when we were correcting homework. Your experience with slope, how could you define it? What do you remember last year? Tell me everything you remember last year about slope. Zoe. Rise over run. That's the thing. Sure. I'm going to put that under how slope is found. Rise over run. Okay. Good. What else do you remember about slope? Anything? Okay. Well, the technical definition of slope is how a line moves across the coordinate plane. Okay. How a line moves across the coordinate plane. How a line moves across the coordinate plane. And that rise over run, that's kind of a shortened version of what we're looking for, which is the difference in y values over the difference in x values. The difference in y values over the difference in x values. Yeah.
So rise over run?
Rise over run is a shortened version of that. Okay. Yet another way to explain it is vertical change, because the y-axis is your vertical axis. That's the difference of the y is the vertical change over the horizontal change. Okay, all three of those kind of define what slope is. You have rise over run, which is the shortest, the easiest one to remember probably, but where that rise and run comes from is we're looking at the difference in the y values compared to the difference in the x values, or vertical change over horizontal change. Now, you'll notice it's kind of written. Scroll down just enough here to make this fit. You can still read the definition. Maybe I'll keep it. Yeah, we'll just keep it like that. It's kind of written in fraction form. Slope is a fraction, but it's also a rate. Remember all the way back at our units about ratios and rates and proportions, things like that. Slope is really a rate that compares the rise to the run and ultimately tells us how a line moves across the corner plane. And we're going to take a look at that today. So it says plot the two given pairs and connect them with a line as straight as you can. Then find the slope, show the change in y and the change in x. Okay, and you always read a graph from left to right. That's kind of a key point there. Just like you read words from left to right on a page. Okay, make sure you read a graph from left to right as well, and we'll see why that is shortly. So first we're going to plot these points here. -4, 2 is there, and -3, 5 is right there. Okay, and we are going to connect these with a line as straight as we can. Look at that beauty right there. Not as great. Okay, but now what we're looking for to find the slope, the rise over the run, the change in y over change in x, from our point on the left. And why do we start with the point on the left? Because you read a graph from left to right. What's the vertical change to get from our first point to our second one? First of all, are we going up the y-axis or down the y-axis? To get from our first point to our second point, are we going up or are we going down? We're going up. Okay, and how far? How far is that vertical change? 3. Right? You can just count. 1, 2, 3. So our vertical change is 3. And then how far do we have to go over? Just 1. Right? So the difference in the y values, 3. The vertical change, 3. The rise, 3. Right? It's all describing how we move across the corner plane. The horizontal change, the run, the change in x, our slope is 3 over 1. Okay? That describes how the line moves, which means if we wanted to go further, we could go up another 3 over another 1, and we land right back on the line again. Right? 1, 6, and 5, 3. Let's take a look at that one. 1, 6 is right here. Oh, no. There's 1, 6. 5, 3 is over here. Making our line. And starting with the point on the left, how do we get to the point on the right? Are we going up the y-axis or are we going down?
Down.
The y-axis. We're going down. How far are we going down? We want to get level with the point here. How far is that? How far did I move? 3. But because I went down 3, the change is a negative 3. Okay? When you go up, the change is positive. When you go down, the change is negative. That's how you can tell the difference. Am I going up or am I going down, right? If I tell you the slope of the line is negative 3 over 2, that tells you that you're going down the y-axis to get from point to point. And then how far is my horizontal change? How far did I go over? 4. And so the slope of this line, how it moves across the coordinate plane, negative 3 over 4. Okay? Negative 3 over 4. And notice where I put that negative sign, I put it with the 3. That's okay. If you want to put that negative sign just out front, right? So it's kind of more in the middle, okay? Negative 3/4, that's fine too. It doesn't make a difference. You can put it with the numerator only or in front of the fraction as a whole. Either way is fine. But that describes how the line moves across the corner plane, down 3, right 4. Okay. Next one, negative 3, negative 3. It's going to put us right here. And 1, 5, way up there. Let's connect these lines here. Or connect the points, I should say, with a line. And what's the slope? Starting with the point on the left, I've got to go all the way up here. How far did I go? Gregory, 8. Okay. My vertical change was 8. And then my horizontal change, how far did I go? 4. And so what's my slope? Rise over run, put it together as a rate. What's my slope? 8 over 4. Now, because this is a fraction, what should I do? Simplify it. What does 8 over 4 simplify it to be?
1/2.
Not 1/2. That'd be 4 over 8.
2.
2 over 1. Right? 8 over 4 equals 2 over 1. Because it's a fraction, you should simplify it. Okay? And check this out. If I use that slope of going up 2 over 1, watch what happens. Up 2 over 1, back on the line. 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 Right? Isn't that neat? Okay? It's the same. 8 over 4, 2 over 1, it's just like the 8 over 4 is making a larger jump. Going up 2 over 1 4 times is the same as going up 8 over 4 once. Equivalent fractions, right? Equivalent rates. Okay? Does this kind of ring a bell from last year a little bit? Light bulbs flickering, remembering? Any questions that you have on it? And where we're headed with this is, slope being able to tell us how a line moves across the coordinate plane. It's going to help us to describe relations going forward. Okay? Describe relations, describe lines, describe relationships going forward. Right? Your homework for tomorrow is My goodness. The other three, and then the 3 questions at the bottom says you are designing a water slide. Which slope above would be best? Okay, and there's a little bit of opinion here, right? Some people like really steep water slides. Some people like lazy river, gradual ones. Okay, but as long as you defend it, you can put whatever you want. Next one, you are designing a ramp for a wheelchair. Which slope above would be best? This one is less opinion. Okay, there are certain slopes that work for wheelchair ramps and certain ones that will not work for wheelchair ramps. Okay, decide which one is going to work the best. And finally, you are designing a staircase. Which slope above would be best? Okay, you think about the staircases that you have at home. Think about, like when you're climbing the staircase. Does it look like that? Do your staircases look like this? Do your staircases look like this? Right? What would be best? And what kind of slope is that going to be? Right? All right. Questions, comments, concerns, complaints, compliments, congratulations. All right, homework for tomorrow. Finish the page. That's high math.